our last speaker of this particular online conference is Ryan Tomeko. Ryan is a member of the Rack core team. So we started off with a member of the Rails core team. We're ending up with a member of the Rack core team. He works at GitHub, and we love GitHub. Everybody loves GitHub, right? And he'll be talking about Rack. And I'm particularly excited because I love Rack, and I think everybody should love Rack. But Rack is sort of, it's the foundation for a lot of the modularity that has happened that made Rails 3 possible. So here we go.
All right. Can you hear me? Can everybody hear me okay?
We can hear you.
Yes, yes, yes? Okay, great. Perfect. Okay, let me hide this chat because this will destroy me. Okay, so this is Rack and Rails 3. I'm Ryan Tomeko, as I mentioned. That's me on a boat. I work for GitHub Inc., and these are some Rack-related projects that I work on as well, so you can check those out. And today I'm going to talk about Rack. I'm going to go through some basics of Rack. I'm going to try to fly through those. Rack's been a pretty big deal for about a year now, so I'm not going to spend too much time on the basics, but I want to make sure we go through those. Then I'm going to have some deep thoughts on Rack, and then finally we're going to get into how Rack influences the design of Rails 3 and look at some ways that you can extend Rails 3 with Rack. And so I like to think of Rack as really two kind of distinct concepts. There's the Rack SPEC, which is really just a document. And then there's Rack the library, which is utility code and kind of set of Rack components for working with applications that follow the Rack SPEC. And it's interesting to note that in Python, these are actually two things. So there's WSGI, which is the specification that Rack is based on, that came out of Python. But then the library is actually a separate library. It's called Python Paste, and more recently a project called WebOb. And so I think it's useful to think of them as two different concepts because they're useful in kind of different ways and come into play at different levels. So I'm going to focus on the Rack SPEC for a little while. One of the things that I love about the Rack SPEC is that it's extremely simple and short. Here I've able to fit it on a single slide. I've taken some liberties. You may have to squint a little bit to see it, but a very easy read. It takes about 2 minutes to run through it, 10 minutes to really understand it well, and it's well worth that time. So I recommend doing that. Don't read it here. Go read it on the web. It's a lot easier. And so what does the Rack SPEC do? It's all about defining a way of expressing and talking about HTTP and expressing HTTP semantics in Ruby using a very simple set of Ruby primitives. And so how do you kind of get to the point where you have those Ruby primitives? And that's really pretty easy. You look at HTTP and you say, well, how would you do this in Ruby? And so here's an HTTP request, and you can see you have the status line, get hello, this is HTTP on the wire. You have a set of headers, and then you would have a request body. So it's like, well, how do we do that in Rack? And Rack chooses to just slam it all in a hash, basically. So you pull out all the information, you build a big hash, you have some information about the server environment there, each one of the HTTP headers has a key and value prefixed with HTTP, and then you have some kind of framework level variables down here, the dotted variable names. And the Rack SPEC goes into exactly what all these have to be, but what's important is now we've defined a way of talking about an HTTP request or a data structure for representing an HTTP request in Ruby that we can use as sort of a standard thing between components. So you kind of go through the same exercise with the response, and you have, again, a status line with an integer status code, a set of headers, and finally a body. And so the way Rack represents this is with a three-element array, the first element being the integer status code, the second element being a hash of headers, and the last element being the body. And the Rack SPEC says that the only thing that the body has to do is respond to each. So you can use an array there, or you can use an IO object as in this second example. So pretty much anything that responds to each can be used in that body. And so now we have our basic data structures in place. We have a request and a response, and that's pretty much all that goes into HTTP. And so the only thing really left is the call model. So how do you actually make an HTTP request on an object? And so quoting from the Rack SPEC now, a Rack application is a Ruby object, not a class, that responds to call. It takes exactly one argument, the environment or the request, and returns an array of exactly 3 values, the status, the headers, and the body, or the response triple. And so kind of the canonical Rack app example is, here's a hello world app. You can see the call method here takes the env argument, which is the request, returns this response triple, and bam, you have the app variable down here. That is a compliant Rack application or endpoint. Here's another way of representing that same application. Since Lambda has a call method, those are basically equivalent as far as Rack is concerned. They both have a call, they both take an end, and they both return a response triple. So it doesn't really matter how you implement Rack applications, just as long as they conform to the Rack spec. And so I think it's important to point out now that we haven't used any Rack code yet. We haven't required the library. We haven't used any Rack APIs. All we're doing here is we're following a convention. And I think that's really powerful. It's just it's simply defining an interface and agreeing to follow it. And you could argue about whether the data structures are pretty or nice, or whether they should be classes instead of this or that. But I would say that doesn't really matter. What matters is that you define it and you agree on it, and that everybody uses the same thing. And we get some pretty big benefits for that. One of those benefits is interoperability between servers and frameworks. And early on in the history of Rack, this is what really kind of let Rack infiltrate everything. This kind of snuck Rack into the back door. This idea that all server environments would work with all frameworks. And if you're familiar with the history of Rails, you'll know that there's really been sort of an upgrade treadmill with servers. At first it was fast CGI, and then 6 months later it was Mongrel and just reverse proxying HTTP, and then Passenger. And so there's been a long history of servers. And before Rack, each framework had to program in support for each one of these servers, or the servers had to program in for each framework. But now we don't have to do that anymore. Servers read HTTP requests off the wire. They turn it into that simple Rack environment hash. They pass that to the call method of whatever application they're configured with. They don't care what framework it's from. The framework does some work, takes the result of that work, puts it in a Rack response triple, returns it back to the server. The server takes the response triple, writes it on the wire as HTTP, and you have interoperability between these things. And as I said early on in Rack, this is a really big deal and really important, and it is really important. But I think as time has went on, we found that this is the least interesting thing about Rack, and that you can actually broaden this concept of interoperability and use the standard interface in more interesting ways. And so to understand that, I want to kind of take a step back and just talk about general architectures. And if you take what you're able to do between servers and frameworks by establishing that standard interface and using that to communicate, you can actually take that and use it at a smaller level and say, if we get all these benefits between servers and frameworks, why can't we split our application into many small modular components and apply that same concept? And so I call it the architecture of intermediaries. Actually, I really don't. I just made that up when I was doing the slideshow. I don't think there's really a term for this general pattern. I was talking to Yehuda in IRC the other day. He's writing something down. There's talks of pipeline architecture or stackable acts or this general concept. But I like this term architecture of intermediaries because it's based in the history of HTTP. And if you look at what makes Rack interesting, we saw it's really very simple. I mean, you just have data structures for HTTP. So I think what makes Rack interesting is that it's really taking HTTP and bringing it up to the level of the application. And if you go back in the history of HTTP, back even before there was a 1.0 spec, there was a great mailing list called WWW Talk, where Tim Berners-Lee and all these guys were discussing sort of the constraints and how HTTP would be designed. And there was this idea, it was envisioned that you wouldn't just have clients and servers, really, But you would also have this concept of intermediaries. And so any given HTTP request would go through some set of intermediaries, and each one of those intermediaries would be able to add some value to the request, perform some service, things like caching or compression or authentication and logging. And so kind of put this diagram together, you have clients on the left, they speak HTTP to maybe a company proxy or maybe not. That company proxy would then hook into some kind of regional proxy. This is an actual like geographical regional proxy, like your county would have a proxy server or something. And then there would be maybe a larger hierarchy of these proxies. Eventually you would get into the destination site, and inside of there you would also see this kind of architecture of intermediaries where it would flow through some service that added compression and auth and logging and load balancing and eventually reach the application. So any request would maybe go through who knows how many server processes or intermediary processes. And long story short, this never really worked out. It did a little bit. We still have this with servers, like the way we just deploy Nginx and Apache. Clearly, you know, that provides things like compression and serving static files, and then passes things through to apps. So you can consider those intermediaries. You also have HTTP caches, and so that works. But you really get the feeling reading these old mailing list threads that they thought that this would play a much bigger role in the overall architecture of the web. And it didn't really work out the way they wanted to. But what's important is they made concessions in the HTTP spec to make sure that this kind of architecture would work. So when somebody would suggest something that would break this model, you know, it would be rejected very quickly because they wanted to make sure this could work out. And it's a good thing they did, because now in Rack we're able to utilize that. Since we're really just talking about HTTP and using HTTP, we can use this architecture of intermediaries and build on that concept. And so we have middleware. And middleware looks a lot like a normal Rack application. It has a call method just like a normal Rack endpoint. The only difference is that it takes, when it's initialized, the Rack endpoint that it should delegate request to. So it assumes that it's sitting in between a requester and some destination site, which may be a chain of more middleware. So in this example, this is a very simple middleware that just takes the response from the downstream component and converts it to uppercase and returns that to the requester. And you can see here we have our the Hello World app that we used previously, and then we pass that into the shout middleware as the first argument. And so now we have the stream variable, which is a new Rack endpoint. So both of them speak the Rack spec, which is the really important part. The Rack spec is kind of like the glue in between these things. They don't need to know about each other. All they need to know is that they speak that standard interface. And then we pass that into a mongrel handler to actually start a server, and that passes to the stream into the application and whatever. And so what we're able to do now is this forms the basis of really an underlying architecture for building HTTP-based applications. And so you can start building very small components. So how small do you make them? And so in Rack, there's a good 15 middleware components. The next slide will list them, but they're very small. Here's one of my favorite examples of middleware. This is Rack ETag. This is part of Rack Core. But you can see that all this thing does is looks at the ETag response header. If it doesn't exist, it'll generate a hash from the body and add that header. And this is really the level that we're building components on. Extremely modular. This can fit into an application anywhere along that Rack pipeline to add this functionality. They're very easy to test because they do a simple thing and have a defined interface on both the front end, the request end coming in, and the request that it makes on the app. So it's very easy to write a test around this. And so you have this extremely modular, simple architecture. And you can see now, getting into the Rack library a little bit more, a majority of the Rack library are these types of middleware components. The ones that we feel would be most commonly used by web applications go into Rack Core. So middleware can do all kinds of things, modify content. They can be behavioral, do things like logging or lock on a mutex, reload code. They can provide routing services and say you have hierarchies of middleware, as we'll see with the new router in Rails 3. And then there's even more middleware in the Rack Contrib project, which is an official Rack project. but we're a lot more liberal with accepting new things into it. Basically, any independent piece of middleware can be submitted to the Rack Contrib project. It's added, it has to meet the submission guidelines, but you see you have a lot more of these in there. And again, it's kind of at this very granular level that you build these things. And then finally, you have a contest that ran starting about, I don't know, 5 or 6 months ago called CodeRack. And in the CodeRack context took submissions for middleware by anybody, and then there was votes and all this kind of stuff. But in the end, there were 99 pieces of middleware submitted. So there's 99 pieces of middleware available on the CodeRack site. So we're getting into the hundreds of pieces of these little components that can be snapped into any Rack application to extend it or add value. And none of those components need to know really about any of the other components or where they fit in the pipeline. That's all kind of pushed to application time where you assemble these things. And so I think that says a lot about the sort of architecture of intermediaries and what we're able to do by simply bringing HTTP up to the application level and using it as an internal application architecture. Okay, so that is my thing on Rack. Now we're going to jump into Rails a little bit and talk about how Rack influenced the design of Rails 3 and how you can use Rails 3 to, or use Rack to extend Rails 3. And when you first go into Rails 3 and get the first boot screen, I thought this was great. You get this list of middleware now right on the boot screen. This is the middleware stack for your application, which we'll see how to customize that. But I thought that was kind of a statement that Rails 3 takes Rack extremely seriously. It's become a major component of ActionController and the HTTP processing layer of Rails. And so most of what I'm going to talk about, it centers around this new component called Action Dispatch. It's a part of ActionPack, and it's largely an extraction of things from ActionController. And I wasn't involved in the development of Rails 3 or Action Dispatch, but I imagine the way it was done is, they kind of looked at ActionController and said, man, what can we break out and turn into this modular Rack architecture? What are the small little pieces we can pull out and turn into middleware? And then we'll just assemble them, and that will be sort of the new ActionController, at least the Rack HTTP dispatching part of ActionController. And so a big part of Action Dispatch is that. It's just a set of middleware that's assembled in front of your application. Also, the code that was in Rails 2.3, because Rack was actually introduced in Rails 2.3 in some form, you could run a Rails application via Rack, and you could use middleware and stuff like that. The internal architecture of Rails wasn't so much Rack-based, but they had begun integrating it. And there was this nice middleware stack concept idea. We'll take a look at that. There's utility objects, Rack request and Action Dispatch request and Action Dispatch response. So the request and response objects that you use in your controllers are now come from this Action Dispatch project. We won't get into that, but I thought it was interesting looking through the code that those are really very simple subclasses of Rack request and Rack response, which are classes in the Rack project that wrap the request environment and the response triple, make it easy to generate a response triple. In either one of them, the request and response are maybe 100 lines of code, if that. And so I thought that was really cool. Rails was able to just layer on top of that and add a few things to get their kind of standard interface and use a lot of Rack there. The entire routing system has been revamped. We'll take a look at that. And then lastly, there is all the integration testing support code is now in Action Dispatch as well. So this is now a very major component of ActionPack. It really separates the Rack dispatching and HTTP dispatching layer from ActionController, and is an interesting component. So in the default middleware stack, as we saw on the environment screen I'm showing here, and this was also in Rails 2.3, although it was a little bit smaller. But I think this is a great way of illustrating this architecture that we're talking about of these modular Rack components, because you can see here this is a fresh Rails application. that you have components from 4 or 5 different projects here. You have Action Dispatch, you have components from Rack, you have Rails Logger, which is a generic Rails component, and then you have the main Action Dispatch components, another Rack component, Action Dispatch again, and then even stuff from Active Record, and then finally Rack application generated from your routes and your controller. And I think that's great. I mean, this is really the goal, is to be able to mix and match these components in whatever way you need to be able to get the functionality that you want. And so, as I mentioned, there's Active Dispatch middleware stack is the component that you use to really manage this pipeline. And I'm not sure where the best place to do this is. I guess anywhere that you have a config object would be fine, but now there's this new config application.rb, and you can certainly get to it from there and use all of the middleware stack methods. So there's use, which as is at the bottom. You can insert middleware before a middleware. You can insert middleware after a middleware. You can swap 2 middlewares, take one out and put one in the same place, or you can just remove a piece of middleware entirely. And so that's really robust. I'd also recommend looking at the implementation of middleware stack. It's really interesting. It's basically an array, so you can perform all kinds of array operations on it, in addition to the ones listed here. And it's very simple and worth a look. So this is another way of adding middleware, and I think this is something that we're still trying to work out. Like, you have this great modular architecture now, and the problem now becomes, how do you manage these things? How do you get middleware into the pipeline? How do you make sure they're in the right place? How do you have extensions that add middleware and things like that? So this is an example I found the other day where somebody took Rack Cache, which is a piece of middleware that implements HTTP gateway caching, and wraps it in one of these new rail ties or plugins, and is able to hook into that config and add the Rack Cache middleware to the middleware pipeline. And this is basically all the code required to do that in the plugin. And then in your Rails app, all you would need to do is install that gem and specify that the Rails cache file be required. And just with that, you have the Rack Cache middleware added to your middleware pipeline, so you get caching just that easily. And so now I want to talk a little bit about the other part of Action Dispatch, the other major piece of Action Dispatch, not just Rack components and being able to manage that Rack pipeline, but also all of the routing has been revamped. There's a really cool project from Josh Peak. It is used by Rails, but it's not Rails specific, and in fact, it's extremely simple. It's a very simple API, maybe 3 methods. And I don't think you would be using this directly in your Rails app necessarily. The routing DSL uses this underneath the hood. But I think the implementation is super interesting, so I wanted to spend some time on it. But basically what we have here is we have the concept of a route set. And so you create a route set. The set object that's passed in basically has a single method, this add route. And it takes as its only argument, or it takes as an argument, a Rack app. So basically, Rack mount routes a set of conditions in a URL pattern to a Rack endpoint. So anything that speaks Rack spec can be routed to given these set of patterns. And it works in that hierarchical style, similar to Rails Metal, where if foo app were to 404, then it would continue trying to match against additional routes until, invoking them, until it finds one that can actually process the request. So foo app is just a Rack app. And then also interesting is that the returned object from the Rack mount route set that's returned is also a Rack app. And so we just have this, you see just Rack spec everywhere. It's become like a very common standard interface. And by doing things like that, you're able to have some pretty interesting abstractions. And so the reason that this works in Rails now is that all of your controller actions are actually individual Rack apps. So not just the controller itself, which I think is also a Rack app and can be called like a Rack app, but also the individual action methods. And the way that this works is, given any controller, I fired up the console here, and was just kind of poking around. Given any controller, you can say controller.action and then the action name, and what's returned to you is one of these ActionController metal components. I believe that's different than the Rails middleware thing. It's specifically for these actions. But the metal action endpoint class or object responds to call and knows how to dispatch requests to a new instance of application controller on the index action. So what this lets you do is make the router extremely simple. It doesn't care what it's dispatching to. The router is now concerned with matching URL patterns and other conditions, and then invoking that rack application. So it's very simple, very elegant. And then that lets you do things that are pretty interesting, like routing, using Rails router to route to other types of rack apps. And so here I have an example, again, pulled just a few days ago. I ran across this, where you have a Sinatra app, which Sinatra is any class that subclass is Sinatra base, is also a rack app, speaks the Rack spec. And so you can take a Sinatra app, if we throw that just under lib, Twitter app, and then in our routes file, require Twitter app, we can now route patterns to that rack app. And so the router is very much not even aware of ActionController or what it's routing to beyond the fact that it speaks this rack protocol. And so I think that's really interesting and a great testament to Rack and the ingenuity of the Rails developers to be able to come up with such a clever way of doing routing. And so that's really all I have. I just want to conclude by saying that, congratulations to the Rails 3 team. I think you guys did a great job, and we're able to do pretty amazing things with Rack. So here's some more stuff on Rack. One that I want to point out specifically is the Rails guides, Rails on Rack, has been updated for Rails 3. So a lot of the middleware stack and action dispatch and the default set of middleware, if you want more information on that, it's all available there, and it's laid out really well. And so that's it. I guess we'll open it up for questions if we have time.
We do. We have about 5 minutes left for questions. So Yehuda has been answering a bunch of questions in the chat again, but there are some new ones coming in. So Zachary Carter asks, does the Rack spec handle async?
No, and the Rack spec is actually bad at async. This has been a topic that comes up quite a bit, but if you remember the call model works by passing in that environment hash and then returning a value. And that's really, really bad for async because it basically requires the stack or that call stack to go all the way down and unwind all the way back up before anything can continue. So we've been discussing this for a while, like what would it take to do, like in a sync rack, or how would you add async to Rack? And I think at the very least you would have to change that call model and either let it yield or register callbacks on a object included in the env or something like that. It breaks the whole middleware model. The middleware model is based on this idea that you have a call stack and each middleware calls the next one. And so that would have to be changed quite a bit in order to support async. But that being said, you could definitely leverage a lot of what's already there in Rack. For instance, you would be able to use the env. There's nothing wrong with that request environment. There's nothing wrong with the response triple, really. You may have to add in some async body writing or being able to produce that response triple in a disconnected way, asynchronously. But so yeah, Rack is not great for async, and that's not something. There's a few people actively working on this, but there's some disagreement in the Rack community as to what direction to take there. So.
Okay. Jacques Crocker asked, can you assert ordering for Rack middleware?
Can you assert ordering?
Yes.
That's a good question. That's actually, I think, one of the kind of outstanding problems with the system. Like now we have a system with all these modular components, and so the problem has really shifted to how do we manage these things? And I think the middleware stack, the Action Dispatch middleware stack, goes a long way in that. But Rack components are really, the best Rack components don't care where they're at, and don't rely on anything really before and after them. However, that's not always possible. A lot of times you need one Rack component to come after another. And so there's been some ideas there. One is that there's actually an HTTP header, again with this intermediary concept. And the idea is that each intermediary would add to this via header and be able to say, oh, okay, this request went through intermediary 1 and intermediary 2 or some server port name or something. And so there's been ideas tossed around about Rack middleware actually modifying the via header in the request environment, and so that other Rack middleware down the line would be able to say, oh, this Rack component hasn't been run yet. But as of right now, there's no real way for a Rack component to introspect its own pipeline. So if you're the fifth thing in the Rack pipeline, if you're the fifth middleware component, there's no way for you to say what's behind me or what's in front of me reliably. And I kind of think that's a good constraint if we can keep it. Ideally, you don't want these components to know really much about where they're situated. So yeah, I hope that answers the question.
Yeah, thanks.
So yeah, I guess no is the answer.
Two things at once now. One is someone was wanting you to show the last slide. So if you could back up the slide. And then the question, the active record query cache showed up in the middleware list. And the question is, what does active record need to do at the HTTP level?
Sure. As for the slide, I think I actually just crashed. I'm beach balling from. Oh,
there we go. You got it.
Event Center. Oh, do I?
Yeah, now it's there.
If somebody else wants, if somebody else wants to take over and move it back, that'd be fine because I don't seem to have any control here. As for the query cache middleware, I'm not positive what that does, but I would imagine that it basically taps into the HTTP request to basically clear out its cache. So the idea being that certain things are safe to cache within the context of a request, but then once a new request comes in, you probably need to restart the cache. That may not be correct. I'd defer to Yehuda or somebody more familiar with the internals of Active Record on that. But it is useful for other components sometimes to tap into that response request cycle and know where they're at, especially things like caching. So yeah.
Okay. Yehuda says that sounds correct. And
okay.
Was this the slide, whoever asked to back up a slide, was this the one you wanted? I'll take that as a yes. Yes, I have control at this point. So, okay, good. Any other questions? We have time for one more. And I think that is a no.
All right, great.
All right.
Well, thanks a lot, everybody, for the opportunity.
Thank you. It was an excellent presentation, and thanks to everyone for attending. And, of course, the speakers were awesome. I learned a lot about Rails 3 today, and I'm even working full-time in Rails 3 at this point. So thanks, everyone.